All right, let's talk about radians. You know, your calculator has radian mode and degree mode. And we've been dealing with degrees. We're going to talk about radians. So first off, I'm going to start with the picture on the right. Notice each of these little chunks represents one radius length. And I can see that it takes 6 and a little bit more than 6 there to actually get the radius around the full circle. And so, you know, if you look at the formula for circumference, that's 2 pi times the radius. Well, 2 pi is about 6.3, which is, you know, a little bit more than 6. So it actually takes 2 pi radius lengths to get around the circle. So that's where the formula for circumference comes from. Fun fact. Well, if I create a central angle where the width is the length of a radius, so I'm going to come back over here to this picture on the left. Notice each of those is a radius. Well, this central angle is called 1 radian. And a radian is basically just, let's be more specific, a central angle measured based off radius lengths. So for example, like in the picture, 1 radian, we can shorten it by rad, because it's a pretty rad concept. 1 radian is the same as 1 radius around the circle, as we can see in that picture. So how many degrees is a full circle? 360. How many radians? Well, how many radius lengths did it take to get around the circle? It was 2 pi. So what that means is that, here we don't need that garbage around here. Because 2 pi radians and 360 degrees, those are both measurements of how we measure angles. And so what we can do is we can just look at equivalent measures here. So I know that 360 degrees is going to equal 2 pi radians. If I divide both of those by 2, I know that 180 is equal to pi radians, and that's actually going to be our most useful conversion factor, is right there. So for example, when I'm converting, like for example, 60 degrees. Well, I know that 360 divided by 6 gets me 60 degrees. So that means that 2 pi divided by 6 is going to get me pi over 3 radians, and that would be how we could do that one. The problem is when I get to 315, where that's not as easily manipulated. A lot of you are in chemistry, where we talk about dimensional analysis, aka unit conversions. Think about it this way. I'm going to multiply by a conversion factor here. I'm converting from degrees, so I want the degrees to cancel out, and I'm going to be left with pi on top. So 315 pi over 180, I'm going to reduce that fraction. I'm going to use a calculator to do it. And the way that I can do that is I can just type in 315 divided by 180. And notice that I did not type pi in. But then I can hit math frac. That will convert it to a decimal for me. If I have that's for TI calculators. If you have a Casio, above the number 8, there should be something that looks like this that switches between fraction and decimal for you. And so you should be getting 7 over 4, but we didn't put the pi in, so we'll just put 7 pi over 4. Okay, I could do the same thing with 225 or 180 degrees, because I want the degrees to cancel and I'm left with pi. So 225 divided by 180. And I get 5 over 4, and we'll put the pi back in there. 5 pi over 4. Cool. Going the other way, well, this time I want the pi's to cancel out. So I can still multiply by this pi over 180. I'll just flip my fraction. So I'll do 180 degrees over pi, because now the pi's cancel. And I get 3 times 180 divided by 4, and I can just type that into my calculator. And I should get 210 degrees. Same thing, 180 over pi. That was not a 210 on the first one. That is, no it was. No it wasn't. 90 plus 30 is 120. My bad. It's not, it's 165, right? Sorry, I don't have my calculator in front of me. I'm gonna actually do this. Okay, 3 times 180 divided by 4. 135, there it is. My bad, sorry, this one's 210. 5 pi over 3. Times 180 divided by 3. 300. Okay. So next we're going to talk about arc length. Arc length is the length of an arc, which sounds like really dumb to say it that way, but arc length of arc. So that should be in like inches, centimeters, meters, stuff like that. Arc measure is what we've been dealing with. And it's like the degree measurement of the arc. So I'm going to show you something. The arc length also is just a portion of the circumference. And so to do that, well, the circumference is 2 pi r, and if I'm looking at a fraction of the circle, I would say, well, how much is it out of 360? All right, so that's a fraction of the circumference. If I was to do the same thing with radians, well, there are 2 pi radians in a full circle. And notice what happens. Just get theta times r. Oh, look at that. I'm going to be erasing that, by the way. So arc length formula is, let's do this in purple, theta times r. Theta is the angle in radians. R is the radius. Well, think about that more. That makes sense. You know, a radian is how many radius lengths it takes to get around the circle, which means that I have the radius. So it's like, okay, how many radius lengths is it to get around? So that's why I take radian times radius. So I'm going to convert 300 300. Sorry, it's really irritating without a calculator here. 300 is 5 pi over 3. I guess we just did that. It's fine. So that is theta, and since my radius is 2 feet, I'm just going to go 5 pi over 3 times 2. I get 10 pi over 3 feet. That's the exact answer. Exact means you don't round it at all. You're going to leave pi in that answer. Approximate so it means you rounded something. So, oh gosh dang it, sorry. So you rounded, you typed it into your calculator, you don't have pi anymore. So the approximate here, I can just type in 10 pi divided by 3. 10 pi divided by 3. Let me get to a calculator. And we get 10.47. All right. So that is arc length. Let's go to sector area. Well, sector area, this is a portion of the area where area was pi r squared. So I can do the same thing where it's either an angle out of 360 times the pi r squared. I'm going to look at it in terms of radians, where it's an angle out of 2 pi times pi r squared. And those cancel, so I get theta r squared over 2. All right, so I'm going to convert 45. The reason I'm converting is so I can get the exact answer, because if I don't use the exact, well, if I don't convert it, then I'm just going to have a bunch of decimals, where to exact you have to convert to radians. That should simplify to pi over 4. So I plug that in. Pi over 4 times 12 squared over 2. Okay, you can just type that all in your calculator as it is. I would do, this is like a 1 here, so I'd go 1 divided by 4 times 12 squared divided by 2. Multiplication, division, it's all commutative. If you wanted to simplify it this way, because it's division, like divide by 4, divide by 2, that's the same as dividing by 8. So that simplifies to 144 pi over 8, which is, I got this, 144 over 8. Which is 18. And our units are going to be meters squared. Area is always in squared. All right, that's it. If you have questions, let me know.